Assembly line balancing is one of the vital techniques of PPC. It's very much important, and as far as the production and as far as the output of the product or the finished goods is concerned, this is very much mandatory to be balanced and to have a flawless implication. See, the work in an assembly line passes through a series of workstations in a uniform time interval, and this time interval is what we call a workstation cycle time. Assembly work performed at each workstation takes its own time, and that depends upon the work elements. Every workstation takes different time. This can be due to several reasons. The main reason would be the operator itself. The operator can be a human, so all humans have different efficiency, they can perform differently, and hence the workstations have their own time. Hence we can say work time at different workstation can be different. The objective of assembly line balancing is to allocate operations to each workstation of the assembly line without violating the precedence and without exceeding the total cycle time. There are certain features, or basically you can call them the tools, which are there, which have been developed over many years for assembly line balancing. First being the cycle time. It is denoted by T suffix C and is given by production time per day upon required output per day. Then we have number of workstations given by N suffix T. It's a theoretical minimum number of workstations that is mandatory or that is required to satisfy the workstation cycle time constant. It is given by NT is equal to summation of T, that is the cycle time, net cycle time basically, upon TC or the cycle time. Then we have cycle efficiency given by eta. It is also known as line efficiency of the assembly line. It is given by N suffix T, that is number of workstation, upon N suffix A, which is the actual number of workstation. See, the number of workstation NT was theoretical minimum. Now the actual number of workstation can differ from organization to organization and plants to plants. So by putting the value of number of workstation N suffix T here, we get the formula of cycle efficiency as summation of T, that is the cycle time, by actual number of workstations into cycle time. Now you need to understand, only T represents the net cycle time and cycle time is given by T suffix C. The main objective of the assembly line balancing can be comparatively viewed as to minimize the number of workstations, that is N suffix T, which is equivalent to the maximizing the cycle efficiency eta. Now we have balance delay. Balance delay is the amount of idle time on production assembly lines which is caused by the uneven division of work amongst operators or stations. It is directly related to line efficiency. Balance delay is given as 1 minus eta.